Water temperature experiment.
Can we see thermal energy? All right, Mackenzie, are you ready to do some experiments? Tell us what we have in this glass.
Hot water.
Touch it. What do you think?
Cold.
Cold water. What do we have in this glass?
Hot water.
Not hot, that's room temperature.
Room temperature.
And then touch this one.
Hot.
Hot water. Right, we're gonna do something with those in a second, but we're gonna do kind of like two experiments at once. In these two little containers, we have cool water and hot water. Can you do me a favor and break this candy cane into two pieces?
Can't.
Kenzie, I would like you to take one piece of candy cane and put it in this bowl, in the cold water, and take the other piece and put it in the warm water. And then we're gonna see what happens to them, if there's a difference between our cold water candy cane and our hot water candy cane after we're done our next experiment.
It looks flat.
It does. We're gonna do our experiment and it's on thermal energy.
Hey, I know what's happening in the hot water.
What?
It's breaking.
You think so?
Yeah, look at that crack.
Oh, nice observation. I wonder how thermal energy will affect the candy canes. Hey, Mackenzie, we want to see what happens when we put the blue food coloring into the cold water. Could you add one drop, please, very gently? One. Okay, let it sit. Into the room temperature water.
It looks like a tornado.
So what's happening to it?
It's getting blue and it kind of looks like a tornado storm and it looks like clouds are coming out of it.
It does look kind of cloudy and it looks like it's all falling to the bottom of the glass. Now let's put them in the room temperature glass. Just one drop. There we go. Leave it. There we go. Is it doing the same thing? Does
Yep.
anything look different?
This one looks like is at the bottom already, and this one looks like it's on the top.
Well, you just put it in, so it takes a little bit of time for it to sink to the bottom. I do think that this glass looks very foggy, and this one is a lot more clear.
It looks a little bit green in there.
And now what happens if we put it in the hot water?
Let's see. I don't know.
Okay, let's see what happens. It's very interesting. It's not moving the same way as the other ones. The other two, the drop sunk right, it started to slowly go to the bottom, but in the hot water, it started to move around. It's moving around differently.
Mama, in these two bowls, it looks like a giant beanstalk.
It does, but look what's happening to the color. What's happening to the color? It's staying pretty still, right? Let's
Whoa.
move this out of the way. Let's see what.
Let's see what happens if we put
So I actually want you to put another drop in the hot water because it looks very different. Okay, stop. So what's happening to the one in the hot water?
It's moving.
It moves around in the hot water.
But now this time it's going the same direction.
Do you know why it's moving?
Because the hot water, there's little flexes in there and they move around.
Well, remember the other day we were talking about molecules, right? So when the molecules are cold, they don't move very much, right? They're very still. But when molecules are heated up, they move a lot faster. So this shows us that when a liquid is hot, that there is more movement.
Oh, I can see the molecules. Little tiny circles.
Well,
There's
I
a
think those
molecule.
are bubbles. Those are bubbles.
Let's do more in the hot water to see what it does.
Even though the glass of water looks the same, the difference in the water temperature causes the molecules that make up the water to behave differently. Molecules that make up matter move faster when they are warmer because they have more thermal energy, and slower when they are colder because they have less thermal energy. These fast-moving molecules in the hot water are pushing the molecules of food coloring around as they move, causing the food coloring to spread faster. what happened to our candy cane?
That one looks a little bit bigger, but that one looks smaller.
Oh, well, what do you mean by smaller? Because the length of our candy canes are the same, maybe slightly smaller. But what do we notice when we look at them? What happened differently in the hot water? Okay, Mackenzie, what happened in the hot water?
So in the hot water, all the red comes off.
All the red stripes came off of the candy cane. That's right. And if we look closely, I don't know if our camera can really detect this, there are bubbles kind of on the outside of it. Oh, I can see some bubbles kind of popping up. Wow. And let's see on our cold water, I still see those bubbles, but not as much of the red has dissolved off of the candy cane. Interesting. What do you think? The thermal energy affected the candy canes the same way in that after a long period of time, they both ended up melting. So, can we see thermal energy?
Yes, we can see thermal energy.